On the afternoon of June 12th, Air India flight AI-171 was departing from Ahmedabad to London. Before this, the aircraft had come from Delhi to Ahmedabad, where routine refueling and boarding took place. The plane took off and climbed normally to about 400 feet, but then suddenly began descending. This incident was shocking because a safe aircraft like the Boeing 787 Dreamliner suddenly falling was a massive shock to the entire aviation industry. The plane crashed on the roof of a hostel near the civil hospital in Ahmedabad, where some people were having their lunch. Of the 242 people on board, only one passenger survived, while the rest lost their lives. Additionally, some people in the hostel also died. Early information indicated that both engines were not working because the engine blades found at the crash site were intact. If the engines had been running, the blades would have been bent or damaged. The possibility of a bird strike was ruled out because bird activity is minimal during the afternoon heat, and no bird remains, smoke or fire were found at the crash site. Foreign object damage was also unlikely since there was no explosion or fire before the crash. The weather was perfectly clear, 37 degrees Celsius, 6 kilometers visibility, and no clouds. From all this, it can be suspected that failure of both engines was the primary cause of the crash. It was also observed that the plane used more runway length than usual during takeoff, which raises suspicion that there was a problem during takeoff itself. In aviation, speeds like V1, VR, and V2 are extremely important. V1 is the decision speed beyond which you cannot safely abort takeoff. If an engine fails before V1, the pilot can abort the takeoff. But if the failure happens after V1, the takeoff must continue. If the second engine also fails immediately after the first, pilots have only a few seconds to react. This is an extremely difficult and stressful situation. The big questions then become, was the aircraft loaded correctly? Was the takeoff from the intersection or the full runway length? Did the ram air turbine RAT deploy or not? And most importantly, were safety protocols followed? DGCA has already issued notices to Air India and Air Asia India for safety violations. In 2020, I myself reported safety issues at Air Asia which were later proven true, but instead of action, I was terminated and the responsible people were promoted. Such incidents raise the question, will investigative agencies conduct fair probes or just blame pilot error as always to close the case? Until the truth comes out, we cannot prevent future accidents.
In aviation, speeds V1, VR, and V2 carry great significance. V1 is called the decision speed, meaning the point until which you can reject takeoff. If a problem like engine failure occurs before V1, you can abort takeoff. But if it occurs after V1, takeoff must continue because the remaining runway length is insufficient to stop the plane safely. Then comes VR, the rotation speed, where the monitoring pilot says rotate and the plane slowly lifts its nose and takes off. Then V2 is the safe climb speed, which is a bit more technical and less relevant here. Now suppose an engine failure happened just before V1. The pilot could have stopped takeoff. But if the failure was after crossing V1, takeoff must proceed, and since thrust is reduced, VR and liftoff point shift forward on the runway. This fits the theory that perhaps one engine failed on the ground and the other shortly after takeoff, causing the longer runway use as Flight Radar 24 data shows.
Let's discuss engine stall. Engine stall occurs when airflow hits engine blades at the wrong angle, causing them to behave as if stopped. However, this does not cause total power loss. The engine still produces about 30 to 40% thrust, accompanied by loud noises like boop, boop, boop. But the footage available shows no such sounds, weakening the stall theory. We tested the dual engine failure theory on a simulator and found that if both engines shut down immediately after takeoff, pilots have only seconds to react. The simulation itself was frightening. Imagining the real scenario is hard. The failure likely occurred at about 100 to 150 feet, high enough that inertia carried the plane to around 400 feet, then it began descending. Videos show the nose slightly pitched up before impact, indicating the pilot made a last attempt to stabilize the plane. The landing gear was not retracted, likely because both engines had failed and the RAT deployed, which only powers essential systems, not the gear. A survivor said the cabin showed green and white lights, which only appear when the aircraft loses both generators and switches to battery mode. This confirms both engines had failed. The question is why? Was the fuel contaminated? If so, why were other flights not affected? Could this be a conspiracy? If yes, it would fall under terrorism and require involvement of major investigative agencies. Finally, another possibility is software fault, like with the 737 MAX, where MCAS wrongly pushed the nose down, leaving pilots no time to react. Maybe the 787 has an unseen software bug triggering incorrect actions. Although unconfirmed, urgent investigation is needed to prevent further accident. Now, let's come to the most important part. What I truly believe happened. This is not just my opinion. I discussed it for 5-6 hours with many people, combining their inputs and my limited understanding to share with you. Ahmedabad Airport's elevation is about 189 feet. Let's round to 200 feet. I want to clarify. I do not want any legal trouble through this video, so some parts are my imagination, which will be marked clearly as fiction on screen. I want to show an important photo Captain Amit Singh shared with me. It shows 3 runway distance lines in Ahmedabad: green, red, and yellow. The green line represents takeoff distance with both engines functioning well. The red line shows the distance when one engine fails at V1. The yellow line shows the actual takeoff distance on June 12th. The yellow line is longer than both others, which is surprising. This could mean that speed was not reached or thrust was low. VTNVL, the aircraft involved, carried 241 passengers and weighed around 205 tons, whereas the maximum takeoff weight is about 220 to 225 tons. So it was almost at its limit. The takeoff speeds with this weight are V1, 151 knots, VR, 153 knots, and V2, 159 knots. This means any problem would have occurred after 151 knots, as that's when the pilot must decide to continue takeoff. Here's a fictional story. When I was flying in the US, a dispatcher, ex-Air India, jokingly told me flights were sometimes overloaded, and pilots would laugh, saying, "Seems the scales are overloaded." He said companies often load extra cargo, causing differences between actual and documented weight. This might have happened here too. If we assume the engine failure happened after V1 and the plane was overloaded, takeoff would have been delayed. The pilot's first shock would be realizing the runway was ending, but the plane was not rotating. Our simulator tests with heavy aircraft in this scenario showed takeoff failed even with both engines working. Another crucial point. On June 21st, 2017, Go Air Flight G8338 had a similar incident. During a flight from Delhi to Mumbai, a bird strike damaged one engine, and the pilot accidentally shut down the second engine, too. The plane flew over Delhi city without engines for some time. Fortunately, the pilot realized the mistake and restarted the engines in time. If we assume in the Ahmedabad crash that one engine failed on the ground and the pilot mistakenly shut down the second, it explains the situation. The plane climbed to 400 feet and then began descending. Boeing 787 has a procedure. If an engine fire or damage occurs, memory items are auto throttle off, thrust idle, fuel control switch off, and fire switch pull. In a stressful situation, the pilot might have accidentally shut down the wrong engine. If both engines failed, gear up would be impossible. Once fuel control and fire switches are off, engines cannot be restarted on Boeing, unlike Airbus. So, after both engines went off, pilots had no options. They pulled the nose up, but the plane stalled, causing the crash. 4 parties are involved: Boeing, Air India, GE, engine maker, and the pilots. But blaming pilots is easiest because they can't defend themselves. When pilots are blamed, insurance payouts are easier. When an accident is attributed to pilot error, who benefits most? The airline, because insurance money is quickly released. However, surprisingly, over the last 2 years, Air India has faced several serious allegations from DGCA, including fines, suspension of training, and show-cause notices. For example, in April 2025, Air India CEO Campbell Wilson and head of flight safety received show-cause notices because of delays in reporting a serious incident. DGCA suspended simulator training at Hyderabad. An 8 million rupees fine was imposed because pilots were being flown excessively, violating duty time regulations and causing fatigue. Again, in June 2025, another notice was issued after Republic TV reported questions about Air India's aircraft maintenance and airworthiness. Here's a fictional story. After the crash, I called many pilot friends. One flying from Europe to India told me that after takeoff at 100 feet, 400 feet, 600 feet, they kept checking the engines repeatedly for any problem, feeling very insecure. Many pilots shared that Air India often operates planes under the Minimum Equipment List, MEL, meaning only the bare minimum systems are working, yet flights are cleared for takeoff. For example, the 787 Dreamliner has 2 weather radars. If one fails, the flight still proceeds with one. When faults arise, engineers often mark them OK on ground, ignoring internal issues. One pilot returning from Europe shared that one weather radar was off and the other failed mid-flight. Luckily, weather was good, or it could have been dangerous. Recently, in an Indigo Srinagar flight incident, a plane flying below saw another aircraft above it, navigating around it. A terrifying scenario. Now, air conditioning and cabin pressure systems are also flown under MEL. On one flight after leaving Ahmedabad, a pilot received a cabin pressure warning and had to return. Another pilot said a single sector can have up to 90 MEL items, sometimes spanning 3 pages. Most are cabin-related defects, like non-reclining seats, entertainment systems not working, leaking water, broken business class seats. If a pilot is handed such a 3-page MEL just 75 minutes before takeoff, to review, brief, conduct security checks, sign fuel papers, and prepare, it's impossible to assess everything properly. This increases risks substantially. Engineering departments have their own problems. Even after privatization, they operate like a PSU and desire full privatization for more authority and benefits. Previously, I raised these small issues, but people dismissed them as normal. This is like the Swiss cheese model, where many small holes align to cause a major accident. We also need to question why large buildings are constructed near airports. Airports are usually built outside cities, yet tall structures surround them. If something goes wrong in Mumbai, disaster is certain. People are voicing concerns. Dirty cabins, tape hanging, AC not working, broken buttons. 3 months ago, I shared a video of the London Flight 787 Dreamliner. Buttons didn't work. Seats jammed. Entertainment failed. If you give customers such poor service, what are you doing behind the scenes for safety? When visible areas are neglected, how good is the maintenance inside? Talking about Boeing 787. Engineer Ed Pearson once stated there are structural gaps. He questioned Boeing's CEO before the U.S. Congress. Boeing denied these claims, but FAA audits cleared him. We have already seen what happened with 737 MAX. In the end, we hope this accident is investigated properly. But sadly, India's Aircraft Accident Investigation Bureau, AIB, is not independent. It falls under the Civil Aviation Ministry. So, can it conduct a fair and impartial probe? We've seen before. In the Ghatkopar accident, where an engine failed, the report blamed the pilot. The cockpit voice recorder, CVR, was off or missing at the time, or tampered with. It feels like a scripted show. How to get away with murder. If evidence disappears, no one is held accountable. Another accident in Uttar Pradesh involved a union minister's death. The report said, probable cause, entry into cloud, spiral, and crash. But the meteorological section said, no clouds. So, which cloud did the pilot enter? So, the question remains, was it only pilot error? Or is it a trending error? A result of fatigue? Or systemic negligence? Finally, I share one more fictional story. Pilots may have now decided to refuse flying aircraft with many MEL defects. This is good because death is first seen by the pilot, not the bank officer, engineer, or manager. Why shouldn't they fly only planes that are fully airworthy? The courts will later decide who is at fault, but accidents happen first. If pilots are always blamed, root causes will never be fixed, and the next accident is inevitable. We must ensure that we learn from this accident and prevent future tragedies. Thank you.